Now that we've learned just about everything there is to know about linear equations, we're going to start solving systems of linear equations. And we'll start off with systems of two linear equations. And geometrically or graphically speaking, what we'll be doing is, if this is the graph of two linear equations, then the solution to the system of two equations is the single point where they intersect. That ordered pair right there. But we're going to solve it we're going to learn two different ways to do it, but we're going to do it without graphing. So, the first method is going to be called the substitution method. So let's take these two linear equations. If you wanted to, you could call that one equation number 1 and that one equation number 2, although it doesn't matter. You could order them the other way if you prefer. And here's the recipe, 3 steps. Step 1, solve either equation for either variable. And I'm going to choose the second equation and I'm going to solve for x. You may suspect why. You may be noticing that the coefficient of x is 1, and it just makes it one step simpler in solving it. So the first thing I will do is take this equation and solve it for x, which would give me x equals, we're going to subtract 2y from both sides. Negative 2y plus 4. So you could think of this as my new equation number 2, absolutely equivalent to the original, just written in another form where it is solved for x. Now that x is equal to this expression, I'll go to the other equation, the one I didn't use, and I'm going to replace the x with this. So I've done step 1. I solved equation number 2 for x. I could have chosen either equation or either variable, so that part's done. Now I'm going to substitute it in and solve. And notice what we're going to get. Equation 1 becomes 4. Instead of x, I'm going to do negative 2y plus 4 in parentheses. Minus 2y equals 6. So again, you can think of this as equation number 1 with a minor substitution we made. We replaced x with a different expression that we determined using equation number 2. And you'll notice that this equation does not have the x in it anymore. Its only variable is y. So we can solve for y. So if I distribute below here, I'm going to get negative 8y plus 16 minus 2y equals 6. And now let's combine like terms, this one and this one. That would be negative 8y, negative 2y. I'll go up here now. Negative 10y plus 16 equals 6. So when I subtract 16 from both sides, that gives me negative 10y equals negative 10. And then dividing both sides by negative 10, we can see that y is equal to 1. Now, of course, that's only half of the answer. We now need to find out what x is, and step number 3 says solve for the remaining variable. So now that I know what y is, y equals 1, I can go back to either one of these two equations and replace the y with its value of 1. So let's do it with equation number 1, and I suggest you may want to do it in both equations just to make sure that you didn't make any arithmetic mistakes. So equation number 1, since we know y is equal to 1, it turns into 4x minus 2 times 1 equals 6. So that's 4x minus 2 equals 6. Add 2 to both sides and we get 4x equals 8. So all I did is added 2 to both sides to get rid of that negative 2. And that's simple to solve for. When you divide both sides by 4, we get, and I'll write it up here, x equals 8 divided by 4, which is 2. If we made no arithmetic mistakes, we're done. But we could at least go back to equation number 2 and in our minds figure out if it looks correct. If x is a 2 and y is a 1, does this equation work out? x is a 2 plus 2 times 1. That gives us 2 plus 2 equals 4. So it does work out. So the way we like to write the ordered pair that solves both equations is as an ordered pair. That is the solution. So if we were to graph these two lines in an xy plane, the one single point where they would both cross, or in other words, the only single point that is on both of the lines, would be 2, 1. All right, let's look at one more example in this video. Solve this system of two equations using the substitution method. So once again, if you wanted to, we could refer to that one as 1, refer to that one as equation 2. And we have to choose one of the variables to solve for in one of the equations and then either variable. I've worked this out before where I solved for equation number 1 for x, and we immediately went into fractions. And I think that would be an excellent practice for you, especially if you need some reviewing on your fractions. Can you pick a variable where we might not jump immediately into fractions? Which equation, which variable? Well, I think it's going to have to be equation number 2. And if I solve for y, notice what's going to happen. Notice all of these numbers are divisible by 2, all of these coefficients, and the number 10 as well. So if I take equation number 2 and solve it for y, I would get 2y is equal to negative 4x plus 10. Now what's my justification for doing that? I subtracted 4x from both sides. And now I'm going to divide everything by 2 to get y by itself, and that gives us y equals negative 2x plus 5. So this is our new equation number 2, just another way of writing the original equation. These two are equivalent. So now I'm going to take this part, this expression, which is equal to y, and I'm going to plug it into the other equation in place of y. So you'll find when we write down the new equation, it's going to have only x's in it. There will be no y's in it. So equation number 1 turns into 5x minus 3y, but y is actually this expression here in parentheses, negative 2x plus 5, equals 18. So notice that is equation number 1. The only replacement we made is we removed the y and replaced it with negative 2x plus 5. So let's solve this for x. 5x minus, let's see, I'm going to distribute. So what is negative 3 times negative 2x? Turns out to be a positive 6x. Negative 3 times 5 is negative 15, equals 18. So those two like terms add up to 11x minus 15 equals 18. And we'll add 15 to both sides. That gives us 11x on the left equals 15 and 18 add up to 33. Divide both sides by 11 to get x all by itself. And that gives us that x is equal to 33 divided by 11 is 3. So that's half of the answer we need. Now we need to find out what y is. So let's go back to maybe to equation number 1. And we see 5x minus 3y is 18. Well, x is a 3. So replace that x with a 3, and we'll get 5 times 3 minus 3y equals 18. So 15 minus 3y equals 18. And I'm going to subtract 15 from both sides, leaving us with a negative 3 on the left and 18 minus 15 on the right. That's a 3. So I just subtracted 15 from both sides. Divide both sides by negative 3, and we get y equals 3 over negative 3 is negative 1. Now, Let's check it with the other equation too. You should plug it into both equations. We used equation number 1 to compute y equals -1. So let's plug x equals 3, y equals -1 into equation number 2 just to verify our results. 4 times 3, x is 3, is 12. 2 times -1 is -2. 12 plus -2 is 10. Correct. So written as an ordered pair, our answer would be x comma y, or 3 comma -1. That's the substitution method for solving a system of two linear equations.